Alright, so this video is going to be on simplifying rational expressions, and I'm going to look at two different situations we have where we're going to simplify. And one of those situations is where we're going to have rational expressions that are being multiplied or divided by each other. And then the other circumstance is going to be when we're looking at complex fractions, which are like fractions within other fractions. So our first example has to do with multiplying and dividing. That. Alright, so this is something that you've learned before, so within that I'm just going to do an example. And really in pre-calc we're not going to simplify a rational expression and have that be the only purpose of the problem. We're going to do that right now because we're reviewing it, but the purpose of our reviewing it is that this is a skill that you need to have that we're going to use in the context of other units, and you're especially going to use it a lot in calculus. So it's something that we want to look at and get more comfortable with. So the instructions for this unit are just going to say something like simplify. In the future, it will probably be within another problem that you'll realize you have to simplify to kind of work things out. So the original problem is going to have the expression x squared plus 4x minus 5 divided by x minus 1, and that expression is being multiplied by x squared minus x minus 12 over x squared plus 12x plus 35. Alright, so what we want to do first is we want to factor this out because we have to see what things are being multiplied together so that we can see what things are being divided, and then those multiplication and division pieces can cancel each other out because they're inverse operations. So right now all I have things that are being added and subtracted and things that are divided, and those are not inverse operations. So the way that it looks right now, I can't cancel anything. But once I figure out what's been multiplied together, then there's a lot that I'll be able to cancel. So for me to factor, these are like pretty typical trinomials. So to factor them, I'm just going to say, for the first one, I need to know what multiplies to negative 5, but adds to positive 4, and that would be positive 5 and negative 1. I also am going to look at what multiplies to negative 12, but adds to negative 1, and that would be negative 4 and 3. And then last, we're going to look at what multiplies to 35, but adds to 12, and that would be 7 and 5. So those are the three sets of information that are going to help us factor this. And then I'm going to go ahead and write it in the factored form. So I have x plus 5 times x minus 1, all divided by x minus 1. There's my first expression. My second expression is going to be x minus 4 and x plus 3 divided by x plus 5 and x plus 7. Alright, so now I can think about what is being divided by itself so that those two things can cancel to make one, or so that those two inverses make each other disappear. So I'm going to change colors so we can see it. I have a factor of x plus 5 on the top. So x plus 5 is being multiplied, but it's also being divided, and so those are inverse operations. They're going to cancel each other out. I also have an x minus 1 on the top and an x minus 1 on the bottom, and so those are going to divide out to be a 1, so they cancel as well. So our final simplified result is going to be just the leftover factors, x minus 4, x plus 3, divided by x plus 7, and that's all we have to do to factor it. We're completely done. Or not factor it, to simplify it, we're completely done. Okay, we're going to do another example. This one is going to be of a problem where we're dividing things. So we're going to have one fraction divided by another fraction. So we've got 3k over 15 k plus 3k squared, and that is going to be divided by another fraction, and that fraction is k minus 2, sorry, that was my computer, over k squared minus k minus 30. And the reason I'm giving you the problem written this way is because it typically freaks students out when they see problems like this. So when you do a problem that looks like this, I want you to remember that we do keep it, change it, flip it. So anytime you have a fraction divided by a fraction, that's what you're going to do with it. So we're going to keep the first fraction the same. That is 3k over 15k plus 3k squared. And I'm going to go ahead and just reverse those on the bottom and write them in the correct order. And just because I think we're used to looking at them in the right order, so it makes the problem a little bit easier for our brains to work with, I guess. And then I change it from a division problem to a multiplication problem. And now I'm going to go ahead and take the bottom fraction and flip it as I move it up here. So k squared minus k minus 30 divided by k minus 2. And now what I've done is I've changed this from a division problem to a multiplication problem, and now I just need to do some factoring, just like before. So I only have one of these that is a trinomial, so I'm going to go ahead and do that one first. So I need to know what multiplies to negative 30, but adds to negative 1, and that would be negative 6 and positive 5. Okay, so the 3k on top, excuse me, is going to stay. And then on the bottom of that, 3k squared plus 15k, we have a GCF of 3, and we have a GCF of k. And so if I take those out, then my leftovers would be k plus 5. So the first expression is all factored. The second expression, we already figured out the numbers. It would be k minus 6 and k plus 5. And then that's all over k minus 2. Okay. So now I'm going to look to see which factors I have that cancel. And so I can see that I have the k plus 5. Those factors are the same, so they're going to divide to equal 1. And then I have the k and the k and the 3 and the 3. You could also have thought of those together as 3k and 3k. Either way, they cancel out. So now we can go ahead and write our leftovers. And so we have on the top k minus 6, on the bottom k minus 2, and that is our simplified answer. Okay, so now we're going to move on and we're going to look at complex fractions. Let's see where that's the end of my page. I'm going to go ahead and jump down here. Okay, so for this we're going to say our heading is complex fractions. And I teach it one way in Math 3, and then I give you guys a little bit of a more advanced method, I guess, in pre-calc that will speed things up a little bit more. So, oops. Okay, so we're going to go ahead and start off with an example, just like with the other one, and the instructions for this are going to say simplify, because that's all we're doing for now. And the example has u squared over u minus 2 plus u minus 2 over 3u, and all of that is being divided by u. So this is a complex fraction because it is a fraction. It's a fraction, right? The whole thing is a fraction, but it's got two different fractions on the top. So we've got fractions within fractions happening here. So the method that we're going to use for complex fractions is, first we have to identify what our common denominator is. And to do that, we need to take the u on the bottom and we need to turn it into a fraction. So I'm going to write that as u over 1. So now I have that written. Sorry, I was guessing as to where that 1 should be. There we go. U over 1. Perfect. All right. So now we have all of those are fractions. And so if we look at this and we want to write our common denominator, we know that our common denominator has to have all of those pieces with it. So we need to have the u minus 2, that was one of the denominators. We need to have the 3u, that was another one. And then the last denominator was just a 1, so it doesn't really contribute anything. So our common denominator is just going to include the u minus 2 and the 3u. So common denominator is going to be u minus 2 and 3u. All right, so what we're going to do next is we're going to say that we're going to take this whole problem and we are going to multiply it by the same thing over itself. So if I multiply it by something over itself, then I am basically multiplying it by 1. So I'm going to multiply it by u minus 2 times 3u over u minus 2 times 3u. So since I am multiplying it by the same thing over itself, then basically what that means I'm doing is I'm multiplying the whole problem by 1. I'm changing what it looks like, but I am not changing what it equals. Okay, so I'm going to color code the stuff that I'm about to do so that hopefully it won't be quite as confusing, and we're going to definitely do this in class. So I'm going to show you this. I'm going to take this part on the top and I'm going to multiply it by that first fraction. Okay, so I'm going to go ahead and write that. My first fraction was u squared over u minus 2, and that is being multiplied by u minus 2 times 3u. Okay, so I'm just showing the work for that. And what you'll see is that the u minus 2 and the u minus 2, that those cancel out, and I end up for that first term just getting u squared times 3u. So that first term gives me 3u to the third. I'm going to drop down quite a bit down here. So that's 3u to the third. Okay, so we just did this in blue, so we took care of this first one. That one's done. Okay, now I'm going to change colors so we can see the work for the next one. And again, I'm going to take this part right here, and I'm going to multiply it by that fraction right there. And I'm going to go ahead and show my work for that. Alright, so I'm taking that fraction, u minus 2 over 3u, and I am multiplying that by u minus 2 times 3u. So now I can see that the 3u and the 3u cancel out, and I have u minus 2 times u minus 2. So I'm going to go ahead and show some work for that. Going to figure out what that equals. So I've got u times u is u squared, u times negative 2 is negative 2u, negative 2 times u is another negative 2u, and then negative 2 times negative 2 is positive 4. So that equals u squared minus 4u plus 4. All right, so that represents this term right here. That's the work that I just did. Okay, so I'm going to go ahead and add that to this right here. So that was my first term. Now I've got plus, and then my other term was u squared minus 4u plus 4. Okay, and we have one last term to do. If you can see, we've got that one term over there on the bottom. So now, I'm going to switch colors again. We'll do purple. So now this one right here, that one right there, is going to be multiplied by the bottom fraction. So my bottom fraction was u over 1. And I'm going to be multiplying that by u minus 2 times 3u. And you'll notice that this time, like, nothing cancels out, right? So we just have to actually multiply all of it. So I have u times 3u gives me 3u squared. So I've got 3u squared, and I'm multiplying that by u minus 2. Okay, so 3u squared times u minus 2, and I'm going to go ahead and distribute that. That gives me 3u to the third minus 6u squared. Okay, so I'm going to go ahead and write this. So I've got over 3u to the third minus 6u squared. Alright, so what I just did is I took something, it had three fractions that were kind of combined in one, and now this whole thing is just one fraction. So all that's left for me to do is kind of combine my like terms on the top and on the bottom and see if I can factor things any further. And so I'm going to go ahead and do that. I've got 3u to the third plus... Wait, that's it. Oh. Yeah, there's not really anything I can do. So I'm just going to write it in black, I guess. I guess that it was different colors was like messing with my brain. So 3u to the third plus u squared minus 4u plus 4. All divided by 3u to the third minus 6u squared. And we can go ahead and we can leave it just like that. So that is the simplified version. So the important part about complex fractions is going to be to recognize what that common denominator is, to then take that common denominator and make it a 1 and multiply it by each piece on the top and the bottom. And what you'll notice happens every single time we do that, I'm going to do this in yellow, is you'll see that one part of the common denominator ends up canceling out. So in our green, one part of the common denominator ended up canceling out. In the purple, we didn't have anything from the common denominator cancel out because that last fraction had a denominator of 1, so there was nothing for it to cancel with.